First of all, I want to thank you for coming. We're going to talk a little bit more about backup as a service. We're here at Cloud Expo. I also want to talk a little bit more about HGST in general. For a lot of people here, HGST is known as the lead disk manufacturer in the world, but we are actually shifting the company and offering other solutions as well. And today I want to talk a couple of things. We got 20 minutes, and I want to talk to you about how one of our customers used our technology to implement a public cloud offering, more specific, a backup as a service offering in combination with CommVault. So a couple of things that I want to go through. So one, what we're currently seeing in the market. Two, how this customer designed their backup criteria and how we implemented it with the HGST storage stack. And then a little reference architecture in conclusion. So first of all, let me take a step back to where we started. So for those who don't know HGST, we are the the old IBM division that created the first disk back in the 1950s. And a couple of weeks ago, I was at a customer and I was talking about our first drive, and he's like, "Wait, here, there's one over here." So I took a picture of it, and I just wanted to show everyone how that exactly looks. That was 5 megabyte in 1956, right? So a lot of things have happened since then. And of course, like in the backup world, a lot of other things have happened. So, but if you look back in the last couple of years, and this, of course, the goal here is to talk about backup as a service. Disk has been adopted in the backup world through, as some of you know, deduplication back in 2005. When deduplication came out, a lot more disk features were added in the backup space and in the backup technologies. And then, of course, some acquisitions happened in 2009. We all know about data domain, EMC Avamar, network, semantic deduplication came out, but also CommVault deduplication came out. So a lot of backup vendors invested in optimizing the way data was stored on disk. So very good for us. We're the disk manufacturer. We love that. A lot more appliances were created, but there was a lot of other stuff happening in the public cloud as well, right? So as you guys can see, Amazon came out in 2006 with a public announcement. Microsoft Azure came out, so Google came out with their offering. And in the meantime, as you can see, we were building our capacities, right? We were increasing our capacities per drive from, multiple gigabytes to now 10 terabyte and in helium seal drive. So if you look at where we've come a long way. So in the meantime, in the middle, you can see that the backup vendors were building dedupe appliances, were increasing their functionality. There's been a lot of adoption of the cloud. A lot of backup vendors have actually adopted the S3 interface, the OpenStack interface, the Azure interface, but at the same time, there was another shift happening that right now we see a lot of customers moving back and trying to build similar services on site. So they want to achieve similar cloud scale prices. So for example, if you look at the public offerings, you can buy half a cent per gig a month. You can store data in a public cloud. Now a lot of the enterprise customers, they want to deploy that themselves. So HGST has taken it on its own to build a cloud in a box, so to speak. So it's an object storage. It's 4.7 petabytes in a rack, and that's where we are. That's where we are today. So we're actually showing it here at the rack right in the beginning, where you see the big CrossFit the theater or movie playing. And so a lot of our customers are now looking at bringing that type of technology on-prem and building their private cloud. And also a lot of ISPs are bringing that type of technology to the table so they can be competitive with other public offerings that are out there. So obviously we are partnering with the backup vendors, and that's what I want to talk to you about today. So HGST, what do we deliver today? We have a whole range of product suites. We're primarily known for our drives, and we have NVMe, SSD, HDD, PC. I mean, you name it, we have it, right? If it comes down to disks and drives. So now we're also adding the active archive system that you can see on the right. That's a fully integrated, as I mentioned. It's a cloud storage system in a rack. So it's a fully integrated software and hardware into a single box for easy deployment into environments where customers want to deploy cloud systems. So we've partnered with CommVault for the main reason that CommVault is a very flexible backup technology. So they're no longer just backup, but if you look at their platform, they do archive, they do sync and share. They have a lot of tools for compliancy requirements. So they do a lot of stuff that that actually allows a user or an enterprise account to build their own backup as a service. Not only backup as a service, but also archive as a service, audit as a service, sync and share as a service. You could do a lot more with that, right? So we've actually integrated with CommVault, and I'll show you what we've done. But we've basically made it integrated in such a way that it's easy to manage and it's kind of transparent for a CommVault user to use our storage targets, because we adopted an S3 or an object interface, and an object interface is different than an NFS or CIFS interface. There's a lot of benefits in the object interface that I'll explain a little bit later, but it does require a direct integration with CommVault in this case to make it transparent for the user. So when we start talking to some first ISPs, they were looking at very simple requirements, but very hard to meet. And you guys are probably very familiar with that. When you're building out a large-scale environment, you have to have something that's easy to scale. So if you look at the customer profile in this case, we're targeting with this platform to large enterprise accounts that are looking at deploying multi-petabytes environments, or ISPs that are looking at deploying a new service and they need a backend cloud infrastructure for that. So customer profile, typically they're looking at something that's distributed across multiple geos, that can deliver compute and storage. They're looking for what's really important, cloud economics. So if you look at, for example, the ISPs today, they're looking at the Amazon, the Googles, all the public offerings that are out there, and they want to compete with that because their local users or customers are looking to store data with their trusted advisor, which could be their local VAR, their local integrator. And so those integrators are actually starting to build more services, and this is what they're looking for. So the other thing is that if you look at the top 5 design criteria when we talked to them, and it was one of the these are the top 5, but it always had to be online, right? Everyone is so used to having their data accessible on their phones. Basically, that's kind of translated into the enterprise world as well, and into backup. So when you want to do a restore, they want it to be fast. And when we had discussions with this particular customer that I'll explain, they actually said, we can no longer do this with tape today because tape is not scalable. Now, it's scalable if you look at the capacities, but it's not scalable if you want to deliver this type of SLA that's equivalent to what's out there today. Because remember, what's out there today that's delivered by public offerings is very competitive. So they wanted something that was always accessible, very easy to do that. Maximum performance, what they wanted to do, what they were trying to tell you with that is that on the maximum performance side is they wanted to make sure that the technology they chose was not limited in performance, and it was able to scale as they would grow their network connectivity. So let's say you're a telco, you want to offer a backup as a service, you want to upgrade your network connectivity as you grow and only when you need it because it's very expensive, right? And definitely in environments where you want to distribute your data across multiple geographical locations. Best ROI, who doesn't want to have that, right? You always want the best cost possible, and the minimal building blocks. So they wanted something that was easily scalable, where they could just add another rack. They didn't want to focus on individual drives. They just wanted something that was completely integrated from the start. So when you start building an environment or an architecture like this, you have to start with the backend. So first of all, this particular customer had multiple locations and wanted something that was easily to fail over, because he didn't like the traditional active-passive or active-active environment. So he wanted something that would be accessible from multiple geographical locations and also be able to tolerate a full data center failure. So in this case, what do we offer? We offer something that can easily distribute data across multiple sites, right? So if you look at Los Angeles, Phoenix, and Las Vegas, the idea is you deploy 3 racks across 3 sites, and each site has the same view. So it's the same effect that you have with public offerings today. You ingest something in Seattle, you get it back out in San Jose. You actually have the same look and feel. You see the same version. They're all consistent. So here, really, the solution here provides a consistent view across multiple sites. On top of that, you can scale it out, of course. So you can scale as you grow. The way that we designed it is that we can add extra racks into an existing environment without having to rebalance your data. So really what we took is we took the concept of what our large-scale providers are doing today with off-the-shelf hardware, and we made it cookie cutter so that it's easy for our customers to deploy. So essentially, you can start with a single rack, and you can add extra racks on the fly as you need more capacity demand, right? So very easy. Now, we're talking about petabytes, right? So a single rack is 4.7 petabytes. This is not small. So if you have 6 racks, you can see that counts up very quickly, and you can scale beyond 6 racks. But the idea behind it is that you have a single namespace, which means you have a single view, which means when you start with a single rack and you store some data, you can still extend the capacity and still maintain that single view. There's no need for extra mount points or namespaces, or you don't have to rebalance data or migrate data. The system does it by itself. So it's very important. It's a very important factor, because if you look at the large cloud scale guys today, they don't care about individual drives anymore. They don't care about individual nodes. They will just replace full racks when enough failures have happened within a rack. And that's kind of the concept we wanted to approach here, because all these systems have self-integrity built in. You can tolerate multiple drive failures, multiple node failures. It has like 15 nines of durability. And so we've extended that to 3 sites and created basically 3 zones, you can create as many zones as you want, but you basically have one availability zone, which means that in Los Angeles, Phoenix, and Las Vegas, they can tolerate a full data center failure. So for example, Las Vegas can go, fall off the earth. I mean, that's maybe a wrong statement here, but you can actually lose a full data center without any impact on your data, which means that your data, let's say you lose Las Vegas, Phoenix and Los Angeles will still be able to service the data, and you don't have to do any active, passive failover. It's global consistent, so you have a single view across all the 3 sites. And the only reason why we can do that is because we are not using a traditional file system. We're not using a block interface. We're using an object interface, which allows us to accomplish this. So what did we change? Initially there was a traditional 2-tier architecture, a 2 data center type of technology there. So we had on primary, so we had the primary storage, which was primarily NAS and SAN. We're all familiar with that, very expensive, which was then replicating to a second tier, eventually replicated to a disaster recovery site, and for long-term purpose, it was stored on tape. So basically, we replaced the 2 tiers in the middle, and actually what we figured out is during the process of, when we did the TCO and the ROI calculations, is that, we could actually go away completely from tape and only put tape in place when there's really compliance reasons to have the tape on a completely different location than the ISP was hosting it itself. So initially, the ISP was thinking, let me just optimize my disk and just still have tape in place. In the end, we actually ended up removing tape completely. So how do we scale? How do we protect that scale? Because this is all about protection, right? So, you're developing a platform that is completely designed to ensure your data is not corrupted, it's consistent, that it's accessible online at all times. Now, we at HGST have identified, we're selling drives in the millions, right, on a yearly basis, but we've get the feedback from our customers on a daily basis that rate volumes or rate sets don't scale, right? If you create a traditional rate 6 and you put a file system on top of it, as capacities increase, your rate rebuild times take longer. And if you want to scale into the petabytes, at a certain point, there is no point where you can actually take backups. Your copy is your final copy, or you can protect it with in different ways. And this is actually how we implement it. So what we did is, instead of storing multiple copies, we actually use an erasure coding technology built into the appliance that distributes the data not only across a single or multiple drives, but also across multiple data centers. So you can actually tolerate a full data center failure, like in that case of the 3 sites, but you're actually only storing one single copy, right? So you're not storing multiple copies, you're not configuring rate sets. We take away the full, we take that completely out of the picture because we're using a built-in erasure coding, and that helps you save a lot of capacity as well. But besides that, it's also the fact that those backup administrators, they don't have to worry anymore about managing replicas. Because one of the major feedback items that we got from our customers is that today, if they do a traditional active-passive or 2 data center approach, they still have to monitor the backup replications. And those the operational cost to manage that, plus to make sure that it is consistent, that's an extreme cost that they just want to get rid of it. They just want to get rid of the headache and the whole management aspect. So we take that out of the equation here. So that's a new technology that actually replaces RAID. So it's built into the system, which means that you can tolerate a full data center failure and a lot more disk failures. Now, how do we do the integration with CommVault? So for those who know how CommVault works, CommVault is supporting multiple media. It supports tape, disk, dedupe disk. They have all sorts of stuff. But we've actually built it into their existing cloud connector. So CommVault already connects into public cloud offerings. And we've optimized it in such a way that we can get we can basically saturate 10 gig Ethernet line speed. So if you look at CommVault, we allow customers to enable dedupe. So you can still enable your deduplication in CommVault. You can still save a lot of capacity by enabling deduplication on the CommVault side. But you can now also store a single dedupe copy on our 3GO dispersion. And so you can not only protect it from a drive failure, but you can also protect it from a data center failure. So in CommVault, it shows up as just a standard target, very easy, recognizable, HGST storage, so you can actually see this is a screenshot of CommVault, very easy to see. It just presents itself as just another storage target, so all it takes for you to implement is essentially redirect your backup policies to the HGST storage target, and everything will continue as is. You can still continue to back up your Exchange servers, your Isilon servers, everything you want, it's still supported. So the last 5 minutes, I just want to talk a little bit more about how it was really implemented. So mind you, this is an ISP, building a service model. So today they're in production. They're offering backup as a service within the cloud as to the cloud. And so their price points are very close to what you could see out there already. So for example, they're offering, and this is all public information, 6 cents a gig a month. And this does not have any extra expense. So for example, you can store data in the cloud at 6 cents a gigabyte a month without having to pay any transaction fee. So with other solutions out there, you have to pay to retrieve it, you have to pay for the transactions or how many times you read it, how many times you write it. In this case, they cut away they got basically out of that business. So they basically are more competitive in that sense because a lot of customers don't want to see that. They just want to be able to access it whenever they want to at no extra cost, right? Because it's kind of a hidden cost. So the way they set it up is they have their primary cloud services. Again, that is still a SAN and NAS primary tier. That's basically including, it's kind of high level, but in there they have their compute resources. They offer a lot of other services, right? So it's not just backup. They have all these other services with containers and so on. And as part of the primary tier, you also have a CommVault stack that then takes care of backing up the primary tier. And then on the back end, they have a long-term retention. So essentially, the primary backup site will back up all the data to data center 1, and the secondary backup site will back up all the data to data center 2. But the beauty of this architecture is that when they lose site 1 or site 2 or site 3, there's no impact on business because as soon as the data gets stored into the long-term retention, it's basically protected across multiple sites, and you can tolerate a full data center failure plus even extra node failures on top of that without any data loss. So they're not using a traditional multi-copy approach. They're actually storing one single copy, but it's distributed across 3 sites, and they can tolerate multiple disk, node, and in this case, an extra data center failure. And then on top of that, they're adding extra services. So they started as a backup as a service, but they actually are now expanding. So if you look here, this is basically a higher level overview of how they back it up. So they enable dedupe on the CommVault side to get more savings out of it. Then they store it into a bucket. So if you know object storage or any of the cloud offerings, you typically have a bucket instead of a mount point. And so in that bucket, you store your data. If you store the data in bucket 1 on data center 1, you can actually immediately read it back out in data center 2 or data center 3. So what they've done is they have some virtual instances of CommVault running standby that they can spin up or actually ready for retrieval. So at all times they have access to the data in a very consistent manner. And then, of course, they start to expand. So they now are also going after customers that have already CommVault or even other solutions in their enterprise accounts, but are looking for a disaster recovery site. So in this case, CommVault, or in this case, customer, let's say, is using CommVault. Let's say it's a small SMB. They cannot afford a secondary data center. They just want a target for them to point to. So now they can actually point the on-prem CommVault into the S3 bucket, or sorry, in the bucket that's running at the ISP's data center, and can use it as a disaster recovery site. Again, very comprehensive, because now they're capturing two markets. So they're offering services in their cloud. They're adding backup services to that, and now they can also add backup or DR services to existing CommVault customers. And so this has just been the first use case that they've gone after. But in the meantime, they've already been adding other services, right? Like the body cams, you see them everywhere right now popping up, but other government services where they need a disaster recovery solution, instead of using tape, they would like to use this type of architecture. So in conclusion, I want to keep it short because, I'm sure the sugar rush is hitting you, or, lunch is hitting you and you're getting a little tired. Oh, so really? Okay, it's the iWatch. Okay, fine. We'll do the iWatch raffle here in a second. So in conclusion, we've fully integrated with CommVault. We have other partners lined up, so CommVault's just the beginning. We're just presenting that because we have a real customer in production. But if you look at the complete stack, we deliver a lot of innovation on our drives, right? So that with the helium-based drives, we actually use 23% less power than the air-based drives. I recommend you to come to our booth and talk about that by itself. I mean, that by itself is a huge, huge win. Then we also have the fact that we have built-in erasure coding and deliver full disaster recovery backup or protection with a single copy. That saves you 50% savings. And then, of course, there is the application, so CommVault itself, that brings a lot of value with their dedupe. So with that, I'd like to thank you for your time. It was short, brief, but now it's time of the hour. We're going to do a iWatch raffle. So for those who haven't given their business cards yet, call Lynn. I'll give 5 more minutes. All right. Wait. Let me put mine in. Okay. All right. All right. So I got. That's interesting. Found Lourdes from MobiDef. Who's Lourdes? Thank you. Congratulations. All right. Thanks, everyone, for joining us. And we're at the booth. If you want some more information on our platform, our drives, and let us know.